Hello students, how are you all? Welcome to Tungal online classes. In the last video we had discussed states of matter which is present in assignment number 3. So in this session I am going to discuss the second chapter in assignment number 3, that is thermodynamics. So I will discuss all the formulae and few concepts briefly, then I will move to bits present in thermodynamics. Thermodynamics deals with the study of feasibility of reaction. It means the reaction is possible or impossible, whether it is spontaneous or non-spontaneous, and heat changes, energy changes in a chemical reaction. Now, to study thermodynamics, we should know few fundamental terms. In that, the first one is system, surroundings, and universe. A small portion of matter which is selected for the thermodynamic study called system. For example, I would like to study about the room. The room is a system. So the surrounding area means which is connected or contact with the system called surroundings. System plus surroundings called universe. Universe meaning is system plus surroundings. System plus surroundings. The small portion of the small portion of universe which is selected for the thermodynamic study called system. So the portion which is contact with the system called surroundings. Universe means system plus surroundings, right? Next term is types of systems. First one is open system. Open system. Second one is closed system, isolated system. Open system means the system in which matter and energy will be transferred. For example, if you took water in a vessel, keep outside in the sunlight, after 2 days the water level decreases and the vessel will be heated, sometimes it will be cooled. It means water is a matter present in a vessel and heat is nothing but energy. There energy changed and matter also changed. It means energy and matter both will be exchanged from system to surroundings and surrounding to system. Next, closed system. Closed system. If you observe closed system, so only energy exchanged, but not matter exchanged, because the reason is if you take a closed vessel, keep outside, it will be heated, otherwise cooled, but not the content inside will not be exchanged with which one, that is outside atmosphere. Hence, it is called closed system. Next, isolated system. Isolated system meaning is the system in which both energy and matter will not be exchanged. Both the energy and matter, neither matter nor energy exchanged. Such system called isolated system. Thermos flask, when you take the tea in a flask, the heat will not be lost and the matter, nothing but a tea or coffee which is present in flask, will not be lost or gained. Heat also lost or gained. No change or no exchange of heat and energy. Such system called isolated system. Next, properties, thermodynamic properties. Different properties are there. First one, extensive property. Second one is intensive property. Extensive property and intensive property. Intensive property. The property which is depending upon quantity of matter called extensive property. Depends. It is depends on depends on quantity of matter. Quantity of matter present in a system depends. Like mass, volume, right? Many properties are there. Mass, volume, internal energy, entropy, enthalpy. Mass, volume, internal energy, entropy, enthalpy. All many are under extensive property. Important in CET point of view. Intensive property. The property which is independent on matter or quantity of matter. It is independent on quantity of matter called, what is that? Intensive property. Examples are for intensive property: melting point, boiling point, molar properties, melting point, next boiling point, freezing point, molar properties. Molar properties are nothing but molar volume, molar heat capacity, molar specific heat, molar enthalpy, molar entropy. These are all under molar properties, are independent on quantity of matter present in a system. Next, surface tension, viscosity also under intensive property. These are properties, students. Next, state function and path function. State function and path function. First one is path function. Path function. It means the property which is depending upon the path of a reaction. So in which direction reaction will be happens, based on that the reaction will be completed. Similarly, state function. State function means the property which is depending upon initial and final states of matter present in a system, called state function. So examples for state function are internal energy, entropy, enthalpy, Gibbs energy. Internal energy, entropy, enthalpy, Gibbs energy, pressure, volume, number of moles. Like this, many more properties are state functions. Those properties are depending upon initial state as well as a final state. For example, delta H if I took, that is equal to delta H final minus delta H initial. It means depending upon initial state as well as final state, that is change. So after this, process, different process. Here the important one is work and heat. Neither state function and nor path function. Very important. This is, which of the following is neither state function nor path function? Work and heat are not state function and not path function. Next, different processes. One is isothermal process. Thermodynamic process are many types. Isothermal process, isochoric process. Next, adiabatic process. Next, isobaric process. Many processes are there. First one is isothermal process. Thermo means temperature. So delta T is equal to 0. The change in temperature in a system will be 0. That is called isothermal process. Isochoric process. Delta V is equal to 0. Change in volume. It means no change in volume in a particular system. That is called isochoric process. Adiabatic process. Q, change in heat, will be 0. That process called adiabatic process. Next, isobaric process. Change in pressure. Iso means same, baro means pressure. no change in pressure, that system called isobaric process. Next, work. So work done by the system, on the system, so that is very very important. Next one is work. Work it is, yeah, W indicated by. Usually the formula is minus P delta V. P is equal to external pressure to change the volume from one area to another area. So that is called work done. This is minus. In chemistry we are taking minus, in physics we will take a plus. So it is P external pressure it is. Right students? Work done in different processes. Isothermal, adiabatic, next isochoric, isobaric processes. But in syllabus isothermal given. Work done in isothermal reversible process, isothermal irreversible process, work done in isothermal compression, expansion, many processes are there. We'll see formulas students. Work done in isothermal, work done in isothermal reversible expansion. Expansion means volume will be increased, pressure should be decreased, that is called expansion. Reversible process, irreversible process. Reversible means both the forward as well as backward. Irreversible means only forward direction but not backward direction. Now, reversible process is work irreversible is equal to minus 2.303 nRT log of V2 by V1 it is V2 by V1. You know pressure and volume relation as per ideal what is that, Boyle's law. Volume is inversely proportional to pressure. V2 by V1 will be taken as P1 by P2. It is work done in reversible isothermal expansion. Similarly, students, there is a big derivation. I am not giving derivations, direct formulas I am making you remember, that's it. Next, work done in isothermal irreversible expansion formula is irreversible expansion, that is minus W is equal to minus P external delta V. It is delta V means V final minus V initial, that is. Next, work done in isothermal reversible compression. Work done in isothermal reversible compression this time, but not expansion. Compression means volume will be decreased, that is called compression. Work done in isothermal reversible compression formula is 2.303 plus it is 2.303 nRT log of V2 by V1 log of V2 by V1 V1 by V2 log V1 by V2 it is V1 by V2, right students? Formulas only you have to remember. For all these formulas there is a derivation students. Derivation no need for us. Next, after this, first law of thermodynamics. You know, energy neither created nor destroyed, but one form of energy can be transferred into another form. That is called first law of thermodynamics. The formula is important students. First law of thermodynamics, that is equal to, formula is delta U is equal to Q plus W. Delta U means change in energy. U indicates energy. In new textbook, energy indicated as U. old textbook E. Q is equal to heat, W is equal to work done. If W is equal to positive, that is work done on the system, W is equal to negative, work done by the system, work done on the system, work done by the system. So signs are very, very important, students. Next, enthalpy. Enthalpy means indicated by H. It means the total heat content of a system at a constant pressure called enthalpy. Once again, the total heat content of a system at a constant pressure called enthalpy. The formula of enthalpy is H is equal to E plus PV, delta H is equal to delta E plus P delta V. It is right. So PV is equal to nRT, we know already. Delta H is equal to delta E plus delta nRT, Change in enthalpy, change in energy, also you can take it as delta U. So delta N is change in number of moles, universal gas constant, T is temperature. If delta N 0, this whole term will be 0, then delta H is equal to delta E, where delta N is equal to number of moles of products minus number of moles of reactants, product moles minus reactant moles. If it is 0, then delta H is equal to delta U, nothing but delta E it is. Next. So then if you shifted here, delta H minus delta E is equal to delta nRT, formula, students. Then if it is negative means delta E is greater than delta H. If it is positive, the whole term will be positive. To get a positive, delta H higher than that of delta U. So which of the following reaction has more delta H than delta U, more delta U than delta H, or delta H is equal to delta U? That should be based on delta N value, which represents product mole minus reactant mole. Next, so if enthalpy change is delta H is negative, that is exothermic reaction, delta H is positive, that is endothermic reaction. We know, students, already delta H is equal to negative, exothermic, delta H is equal to positive, that is endothermic reaction. Heat released, heat absorbed. Next, standard conditions, STP conditions are, so temperature should be 298 Kelvin in thermodynamics chapter, pressure is 1 atm, and all the reactants and products must be in their physical standard states, right? Standard state in the sense, carbon standard state is graphite form. So water should be liquid state, hydrogen should be in gaseous state, H2 in gaseous state, like that. So next, enthalpy of reaction. Enthalpy of reaction means the change in heat content at constant temperature for a reaction called enthalpy of a reaction. So for example, reactant converted into product. So enthalpy of reaction, change in enthalpy of reaction indicated by delta reaction HA. It is equal to sum of the enthalpies of products minus enthalpies of reactants. It means product enthalpies are there, heat content, and reactant heat content. Product heat content minus reactant heat content, that is enthalpy of a reaction. Next, enthalpy of bond dissociation. Enthalpy of bond dissociation. It is also called bond dissociation enthalpy. For example, H plus B.R gives rise to 2HBr. Right, students? These bonds will be broken. Right? Now, enthalpy of bond dissociation formula is reactants enthalpies of dissociation minus product enthalpies. It means bond dissociation energy formula will be, so that is enthalpies of reactants minus enthalpies of products. Reactant minus product. It's a reverse formula, very, very important. Next, combustion. You know already, combustion reaction, students, enthalpy of combustion. Enthalpy of dissociation means the amount of energy required to break 1 mole of bonds, called enthalpy of bond dissociation. Amount of enthalpy required for combustion of 1 mole of compound into carbon dioxide and H2O. Combustion always exothermic because heat will be released. So combustion, organic compounds on combustion, on heating, then gives rise to carbon dioxide and H2O. So these many problems are there, we'll solve now. Next, after that, enthalpy of neutralization. Enthalpy of neutralization. Neutralization means the amount of heat released when 1 mole of acid neutralized with the base. It means during the neutralization of acid with the base, the amount of heat released is called enthalpy of neutralization, students. There are strong acid neutralized with the strong base, strong acid neutralized with the weak base, weak acid strong base, weak acid weak base, right? Enthalpy of neutralization of strong acid and strong base is greater than that of strong acid weak base is equal to weak acid strong base greater than weak acid weak base. It means strength of acid and base increases. During the neutralization, the releasing energy will be more than that of weak acid and weak base. Examples for strong acid, that is HCl, strong base is NaOH, and weak acid is CH3COOH, weak base is NH4OH. Ammonium hydroxide is a weak base. So very, very important, enthalpy of neutralization, exothermic, energy will be released here. Next, enthalpy of formation. In CET, formation question they are expecting. It means the total heat content released during the formation of 1 mole of compound. Product must be 1 mole in the formation. Very, very important. Enthalpy of formation. Enthalpy of formation means product must be 1 mole. For example, carbon dioxide formation I am taking. Carbon dioxide formation. During the carbon dioxide formation, the carbon dioxide must be 1 mole formed from the carbon and oxygen. It is graphite. Graphite is the thermodynamically stable one. Electropic modification of carbon, diamond and graphite. Graphite is more thermodynamically stable when compared with diamond. That's why 1 carbon and 1 oxygen gas gives 1 mole of product. This reaction is called enthalpy of formation because 1 mole of product formed from their constituents, nothing but in their standard states. If you take diamond, it is not enthalpy of formation. Standard state of carbon is graphite. Standard state of hydrogen is H2 gas. Standard state of oxygen is O2 gas. Standard state of water is H2O liquid. Standard state of sulfur is S8. Phosphorus is P4. Sodium is sodium solid. The definition is amount of heat released during the formation of 1 mole of compound from their constituent elements in their standard state, but not in any other state, then only called enthalpy of formation. Which of the following is enthalpy of formation? Simple questions they are expecting as per this data. Next, enthalpy of formation formula is product enthalpy minus reactant enthalpy. Product enthalpy minus reactant enthalpy. Next one, enthalpy of sublimation. Enthalpy of sublimation. Sublimation means amount of heat required to convert the solid into 1 mole of gas, called enthalpy of sublimation. So now solid first into liquid, that is called melting. Next liquid converted into gas, that is called boiling. First one is melting, second one is boiling. First one is liquefaction, second one is what is that? Vaporization. Now it is nothing but melting plus boiling. Melting plus boiling. Enthalpy of melting plus enthalpy of boiling, students. Okay. Next. Enthalpy of solution. Solution meaning is dissolution it is. For example, NaCl solid, it should be break into Na plus and Cl minus ion. So that breaking energy called lattice enthalpy. After that, these ions are dissolved in water with H plus H plus Cl minus, OH minus Na plus. That is called dissolution. First, NaCl solid broken into ions, that is called lattice enthalpy. These ions should be dissolved, that is called hydration enthalpy. Simply, enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy. Lattice enthalpy plus hydration enthalpy. Lattice enthalpy must be lower, hydration enthalpy must be higher, then only solubility will be increased. Why lattice enthalpy lower? With the least amount of energy, if you break, easy to form ions, the ions will be easily soluble. So hence lattice enthalpy must be lower, hydration enthalpy must be higher, then dissolution will be more, enthalpy of solution will be more. Next, Hess law. Hess law we know, students, already. So many problems are there based on Hess law. Need to solve number of numericals on in your material and also in the textbook also. Hess law. The total heat content of a system is same whether the reaction takes place in the single step, otherwise many steps. For example, A gives rise to D, it is. Otherwise A to B, B to C, C to D. Right? So here it is Q, it is Q1, it is Q2, it is Q3. Capital Q is equal to Q1 plus Q2 plus Q3. It means the total heat content of a system is same whether the reaction takes place in a single step or several steps. This law is useful to find the enthalpy of change in allotropic modifications, enthalpy of intermediate formation, lattice enthalpy, and for many applications we will use this Hess law. Next, entropy. Enthalpy completed. Entropy. Entropy nothing but entropy. Entropy. Entropy indicated by S. It is nothing but the randomness or disorder of molecules in a system called entropy. For example, water flow from high level to low level. For example, water present in the water tank in the first floor. If there is a leakage, water flow from tank to the ground. Then in the water tank, water molecules in the order. When comes down, then obviously there is no order, they will spread in all directions. That is called disorder. Disorder increases, entropy also increases. Randomness. It is a state function which is depending upon initial state as well as final state. Delta S is equal to S final minus S initial. State function it is. Next, after this, entropy formula is system plus surroundings. Entropy total is equal to delta S of system plus delta S of surroundings. Delta S of system plus delta. Delta S for a system is equal to delta H by T. Delta H by T. If an entropy of vaporization is equal to enthalpy of vaporization by temperature. Entropy of melting is equal to enthalpy of melting by temperature. Easy formula it is. Next. So if there is a reaction given, reactant gives rise to product, delta S, change in entropy of a reaction is equal to entropy of products minus entropy of reactants. Disorder in product minus disorder in reactants. Right, students? Next. After that, second law of thermodynamics. First law completed, second law of thermodynamics. As per second law is nothing but heat flow from high temperature to low temperature, but it cannot flow from low temperature to high temperature. Water flow from high level to low level, but not from low level to high level. Right? Gas flow from high pressure to low pressure, but not from low pressure to high pressure. This is called second law of thermodynamics. Right, students? So spontaneity. Next one is spontaneity. Spontaneity meaning is spontaneity. Spontaneity means the reaction which will be happened on its own called spontaneous reaction. The phenomenon called spontaneity. High level to low level water flows. Water flow from high level to low level on its own. In high level, there is an order in the water molecules. When comes to the ground level, then they will spread in all the direction. Disorder increases, entropy increases. It means for spontaneity, delta S must be positive. It means disorder more. All the spontaneous reactions has more disorder. Next, delta H must be negative. It means exothermic reactions, most of the 90% of the exothermic reactions are spontaneous. On their own, it will be happen. Right, students? These two conditions remember for spontaneity. Next, third law of thermodynamics. Third law is entropy of pure and perfectly crystalline substance is equal to 0. Gases, if you observe, those are moving apart from each other in all directions. Disorder is more, disorder nothing but entropy more positive. Liquid somewhat disorder, only somewhat, which one that is entropy. After that, solids are tightly held together by strong bonds, hence there is no movement in the atoms, so there is no disorder, complete order in the solids. Hence, solids has no disorder. No disorder means no entropy. No entropy means disorder will be 0. Nothing but entropy 0. That is called third law. The entropy of pure and perfectly crystalline substance at absolute temperature called, which one? Absolute temperature is equal to 0. This law called third law of thermodynamics. Next, Gibbs energy. Gibbs energy. Very important it is. So all the reactions or whatever the component in the universe, that stability should be explained by a physical quantity called Gibbs energy, indicated by Z. Z is equal to H minus Ts. H minus Ts. So useful work done by the system called Gibbs energy, nothing but. So delta H minus T delta S it is. That is delta G, change in Gibbs energy. Standard means the change in Gibbs energy under standard conditions called standard change in Gibbs energy. Right? This is the formula, very important. If it is system here. If it is surroundings here. Right, students? Then delta Z is equal to, there is another formula, delta Z is equal to minus RT ln K it is. K means equilibrium constant, right? So K means equilibrium constant. It is delta Z naught, it is under standard conditions, where K is equal to e power minus delta G naught by minus delta G naught by RT it is, RT. You can take it as delta Z naught is equal to, instead of ln's, I would like to take logarithms by taking minus 2.3023 RT log base 10 K equilibrium. Then K is equal to, so 10 power minus 2.303 RT by, what is that? Minus 2.303 delta G naught by, plus it is RT this. Right, students? So like this, you need to consider by G naught by 2.303 RT. 2.303 RT it is. 10 power delta G naught by 2.303 RT. It is 10 power. Okay. So these are the formulas for delta G, Gibbs free energy change, the useful work done by the system called Gibbs free energy change. If delta G is negative, that reaction is called spontaneous reaction. Delta G is positive, that reaction called non-spontaneous reaction. Non-spontaneous meaning is the reaction will not be happened on its own. By external agency only it will be happened. Spontaneous means the reaction will be happened on its own. That is called spontaneous reaction. For spontaneous reaction here, delta H must be negative, T delta S must be positive. Positive into negative, negative. Negative becomes more negative. Delta G negative, it is a spontaneous reaction. It means for spontaneous reaction at all temperatures, delta H must be negative, delta S must be positive. Should be exothermic reaction, entropy or disorder must be very high. Students, this is under a brief, simple synopsis regarding thermodynamics chapter. I gave only formulas but not derivations and full information regarding thermodynamics. And you follow the remaining concepts also. I gave only important formulas. So let us discuss few bits from the thermodynamics chapter. Okay, students, in your assignment, bit number 26 to 50 belongs to thermodynamics bits. Among these, I will discuss few bits now. Okay, first, the object under thermodynamical study called. Any object under thermodynamical study called system. Right, students? If I took this room, that is under system. The first law of thermodynamics is energy neither created nor destroyed. Q is equal to delta E plus W. So this is system. Plus W means work done on the system. Minus W means work done by the system. Plus delta E means energy released by the system. Next, energy absorbed by the system. Right, students? Next. Okay, next after that, enthalpy of combustion, it means it is standard, meaning standard change in enthalpy of combustion. Once again, standard change in enthalpy of combustion of graphite is minus 393.5 kilojoules per mole. The standard enthalpy of CO2 is, so combustion of C forms, what is that, students? I am erasing this, the first one. So here I am writing, students. Yeah. C graphite plus oxygen gas gives rise to CO2 gas. It is. C graphite value is minus 393.5. Indirectly, CO2 formation only takes place by this energy. Then enthalpy of graphite is equal to enthalpy of CO2. Enthalpy of combustion leads to the formation of carbon dioxide. Enthalpy of combustion of graphite is equal to enthalpy of formation of CO2. Enthalpy of combustion of graphite carbon is equal to enthalpy of formation of CO2. It is enthalpy of formation of CO2. Answer will be same. It is minus 393.5. Here also minus 393.5. 32. Heat of neutralization is least in the neutralization of. I gave clearly. Strong acid, strong base neutralization releases more energy than strong acid, weak base, and weak acid, strong base, and weak acid and weak base. It means here they are asking least. Least will be happened in weak acid and weak base neutralization. It means the heat released by the neutralization of weak acid and weak base will be very low. So answer will be, so weak acid, weak base it is. Ammonium hydroxide is a weak base, acetic acid is a weak acid. But if you observe, NaOH is a strong base, neglect. Strong base and strong acid, neglect. And it is a strong acid, neglect. We want weak acid and weak base, then only least energy released during the neutralization. Next. Okay students, next bit. Which of the following is non-spontaneous reaction? Non-spontaneous meaning is, spontaneous means high level to low level, high pressure to low pressure, high temperature to low temperature. Reverse one is a non-spontaneous. Heat flow from hot end to cool end. Yes, high temperature to low temperature, correct. Water flow from high level to low level. Yes, spontaneous, high level to low level. Gas flow from low pressure to high pressure. Low pressure to high pressure, never. It should be from high pressure to low pressure. So that's why C is non-spontaneous. Gas flow from high pressure to low pressure. Yes, it is correct. So option C correct, students, to this question. Next. 35. For spontaneous process at all temperatures. I gave students already. Spontaneous means water flow from high level to low level. Yet in water tank, water should be in particular order. When it comes down, obviously there is a disorder. Disorder increases delta S positive, and delta H must be negative. All exothermic reactions, and entropy is positive. In such cases, I think positive and negative. Disorder more, and it should be exothermic reaction. Delta H is negative, then only it is a spontaneous reaction. Few exceptions are there. Majority of the reactions follows this condition only. Enthalpy of a perfectly crystalline solid at a absolute zero temperature is. It is a third law, students. The enthalpy of pure and perfectly crystalline substance is zero because solids are arranged in great order. There is no disorder. No disorder means disorder will be zero. That is, it is third law. And this question is second law, students. Second law of thermodynamics, third law of thermodynamics. Next. Okay students, next bit, that is work done by the system is plus 10 again. Work done by the system. The increase in internal energy of a system was 30 joules. The heat supplied to system is heat required. So our formula is delta U is equal to Q plus W actually. Where Q required for us, Q is equal to delta U minus W. Right students, it is the formula. So then delta U is equal to change in internal energy is 30 joules minus next. So that is work done by the system is 10, that is minus 10 actually. Right, students? Then totally 30 minus into minus plus, that is 40. Right? So answer will be option C, correct, students. Next. After this. Actually, here also work done by the system means minus W. When shifted it is plus W, it is plus, then directly you can take value, then plus 10. So like this also we can take. Minus W means by the system. So then if you shifted here plus W, then 30 W is equal to 10, totally 40 kilojoules per mole. Okay. Next, after this, N2 plus 2O2 gives rise to 2NO2. Delta H is 66 kilojoules given. For the formation of 2 moles of NO2, this much of energy. Molar heat formation of NO2 will be. Molar heat formation means amount of energy required to form 1 mole of compound. That is called molar heat formation. 1 mole. Here, for 2 moles of NO2, 2 moles of NO2, this is the energy required. Molar heat meaning is for us for 1 mole only. 2 moles 66 kilojoules. Molar heat formation means per 1 mole how many kilojoules? Then it should become half. Half in the sense 33. It is plus, it is also plus. Option C correct, 33 kilojoules. 41. Thermodynamics is not concerned about. So it explains the energy changes in a chemical reaction, correct? Extent of reaction, how much reaction will be completed, yes it can. Rate of reaction should be studied in chemical kinetics but not in thermodynamics. Hence, it should not be concerned about rate of reaction, nothing but a speed of reaction. Next, feasibility of a reaction, whether the reaction is completed or not completed, possible or impossible, it should be studied in thermodynamics chapter. So, option C correct. 44. The enthalpy of formation of a compound is, during the formation of enthalpy or during the formation of compound, heat may be released, heat may be absorbed. If released positive, if absorbed, if released negative, if absorbed positive. It means exothermic, otherwise endothermic. It may be positive value, otherwise negative value. Heat of a reaction or a formation may be negative or positive. It may be positive, otherwise negative. Right? Next. Okay, students, next bit. 43. Carbon plus O2 gives rise to CO2. Delta H is taken as X. It is X. Carbon plus half O2 is equal to CO. Delta H is equal to Y. CO plus half O2 is equal to CO2. Delta H is equal to Z. The relation between A, B and C is. Observe, students. So, I am taking like this. From these two, I can get the first one, A, that is. When I flip, otherwise when I keep as it is, students observe, Y plus Z, CO cancel, C plus half O2, 1 O2, C plus half and half, 1 O2 gives rise to CO2. To get X, Y and Z must be added. Hence, X is equal to Y plus Z. X is equal to Y plus Z is the right answer. Haslop problem, very, very important it is. Next. Enthalpy of sublimation of a substance is equal to, sublimation is nothing but solid directly converted into gas. First solid into liquid, that is called fusion. Liquid into gas, that is called vaporization. Then only solid converted into gas. It means fusion plus vaporization. That is. So, fusion plus vaporization. Enthalpy of fusion plus enthalpy of vaporization is nothing but enthalpy of sublimation. Next. 48. If the bond enthalpies of HHBr and HBr given, and what is the enthalpy of the reaction? Bond energy is given, the formula is, I am solving here students by erasing these two questions. Right. Enthalpy of reaction is equal to bond enthalpies of reactants minus bond enthalpies of products. Yes. Reactants, what are they? Hydrogen, it is HH bond, hydrogen gas, plus B.R bond. Br2 meaning is Br bond should be broken, minus 2 into HBr bond, it is HBr bond. Right, students? HBr means HBr bond formed. H2 means HH bond broken. Br2 means Br bond must be broken. And these are products and these are reactants. Values are given, students. For HH 192 it is, plus Br 364 it is. Next, minus HH will be 433 it is. 433 it is. Next, Br is 192 it is. 192 it is. Next, and HBr is last value 364 it is. There is 2 into 364. If it is 1 HBr, 1 into 364, 2 HBr, 2 into 364, 3 HBr, 3 into 364. Students, okay? Then on solving, you will get answer. Finally, the answer will be minus 103 kilojoule per mole. So option D correct, students. Enthalpy of bond energy of reactants minus products. Bond energy given formula will be reactants minus products. Okay. Next. After that, next bit is, okay, students, next bit, the reaction in which delta H greater than delta U will be. First of all, relation delta H is equal to delta U plus delta N RT. Right, students, relation. Delta N is equal to number of moles of products minus number of moles of reactants. Right? Number of moles of product minus number of moles of reactants. Okay. So now delta H minus delta U. Delta H minus delta U is equal to delta N RT. Formula it is. If delta N is positive, then the whole value is positive. Positive means this value must be higher than this. 10 minus 5, then you will get plus 5. So delta N value is positive, then delta H greater than delta U. Right? It is our condition. Delta N positive in which option? Check. 2 moles, it is 1 plus 1, totally 2. 1 plus 1, 2. 2 products minus 2 reactants, 0. Not satisfied. We want positive delta N. Here solid should not be considered, neglected. Hence, solid neglect. Product 1 gas minus 0, 1 it is. Delta N 1 means positive. Positive means delta H greater than delta U. Option B correct to this. Next, 2 minus 1 plus 3, 4. 2 minus 4 minus 2. Minus 2 means we want positive but not negative. Wrong. So, liquid also not considered. 1 minus 3. 1 plus 2, 3. 1 minus 3 is equal to minus 2. Minus not required. For us delta N positive, then only delta H greater than delta. If this is positive, then this value greater than this value. Students, with this bits from Thermodynamics chapter completed. Bit number 26 to 49, nothing but 50 up to 50. These bits belongs to Thermodynamics. I have discussed a few bits. You solve remaining. Have any doubts, post in our group. Right? And in these bits, I gave exemplar problems and also previous KCET questions included along with normal bits. Okay, we will continue in the next video.